wonderful learning individuals. It is a pleasure. How are you all doing today? It is so great to have you. Thank you also so much for pressing the play button. I am Johnny, your host with HomeCountry Mathematics. Please feel free to stay and to also learn, because mathematics can really be fun. Now, let us learn some maths together, shall we? All right, guys and gals, as usual, it is great to have you. Thank you for stopping by. Thank you for learning along. I really, truly appreciate you. Here to help all you students that could use some extra additional mathematics support. I am here for you. Also doing this for you parents. Let's go. Okay, we are continuing on with Unit A, Section 1-2, adding and subtracting rational numbers. All right, this is so much fun. What do you mean it is? Math is fun. Let's go. All right, we're going to continue on doing this. Again, we've been working with negative positive integers. We've done some negative positive decimals. And now we're working on negative positive fractions. Let's do this. Quickly, I'm going to look at this and I can see, well, the easiest, quickest thing to do, obviously, we're adding and subtracting fractions, right? So we need to find that common denominator. That's normal process, okay, when dealing with fractions. All right, so the easiest thing to do would be just straight multiply the two denominators, right, which we can. Another thing you may want to check out is to find out prime numbers list. Like, do a quick search, prime numbers list. Does 55 fall in as a prime number? Well, if you think about it, it really doesn't, because 55 can be divided obviously between 11 and 5, right? So it's not a prime number. So there is a chance that we may or may not be reducing. It's hard to say. It just depends on our numerator portions, okay? All right, let's do this. We will just straight multiply and see what we get. 55, I have decided, is going to be our denominator. Don't forget the sign, okay? The sign does not change, so carry it forward. We have 5 times 4 is 20, plus 11 times 3, which is 33. Now, guys and gals, if you need any extra support with fractions, I do have a playlist. One of the playlists, I do a bunch of fractions, and I give a lot of extra additional advice, tips, support, tips and tricks. So please feel free to check out that series. Great to have you, and we'll see you soon. Okay, so the integer addition is the same. We have a negative 20 plus 33, right? As we can all see, 33, if we ignore the signs, just ignore them, 33 is the larger value, right? 33 is greater than 20. So that means we're going to have many more jumps with 33, obviously. So that means, my point is, that our final answer is going to be positive because 33 is the larger number, correct? So I can do simple subtraction. because I know that the signs are different. They're both different. One's a negative, one's a positive. 33 subtracting 20. We get 3 and 1, right? Okay, so I'm going to clean things up. We know we've determined that our final answer is going to be a positive 13, okay? Continuing the work. 13, right? 13. And I'll do this. And then you just need to ask yourself at this point, is 13 a prime number? Right? It's just the quickest way of figuring out if you can reduce or not. And 13, in fact, is a prime number. Okay? So therefore, that means we are done. There is no more reducing. Oh. I must like doing that. That was the wrong button. That's okay. It's all good. All right, let's do another. I will check my answers later. I'm just kind of grinding these out for you guys and gals. We got negative 2/5 plus 17 over 20. All right, there we go. There's our common denominator. I don't want to go greater than 20. Because why, right? We know that 20 can be divided by 5. So I am making the determination that 20 is going to be our common denominator. Okay? 20. Negative 2/5 plus 17 over 20. All right? Don't forget your sign. Always bring your signs over. Okay? It's easy to kind of forget or overlook. It happens. It's kind of one of my tips, right? To help you remember, right? You're going to have to kind of just pay attention to things, right? It's easy to make mistakes. Again, I believe in every single one of you to be successful at doing this. Also, everyone that is learning and watching along with you also supports you. Let's go. Okay, 4 times 2 is 8 plus, this is unchanged because our denominators are the same. Again, I recommend you check out that fractions series, okay? 17 has the sign positive. Therefore, our answer is going to be positive. We have different signs, negative and a positive. We can simply just subtract. I already know that my answer is going to be a positive. So, was it 9, 10, 11, 12, 13, 14, 15, 16, 17. 9 and 8. Over 20. 9 is factorable. It can be divided by 3, right? That's right, obvious. We know 3 times 3 is 9. So that automatically tells us 9's not a prime number, right? Because it's not. It can be reduced, factored and reduced. Same with 20. But we have an odd number here and an even number here. And, well, we know 3 doesn't go into 20, so we really can't factor 3 out of that. We can divide 3 out of 20, but we are going to end up with a decimal return, which is not what we want. We want whole numbers with fractions, right? So I think that is, I'm going to leave it at that. I think that's it. Oh, did I do that again? I really don't know how I do that. Okay, there we go. Must be some button I click. There we go. All right. Okay, let's continue. That's our next one. Negative 4/15 plus negative. I always put the negative with my numerator. It's just habit. It can sit in front here. That's fine. But I typically put it up with my numerator. So we have negative 4/15 plus a negative 9/16. Okay? Again, we have those weird, they're not really common with each other, right? We know 3 times 5 gives us 15. We know 2 and 8 gives us 16. We know 4 and 4 gives us 16. But obviously 3 and 5 doesn't go into 16 nicely. So, whoops, silly me. Let's do this. Just trying to think of what numbers go with that, right? I'm trying to avoid just straight multiplying this. I mean, I can. There's nothing that says I can't. We just got to be aware that we're going to have to reduce, right? So if I go like this, 15 times 16, that's going to give us what? So let's do this on a calculator to try to save some time. 15 times 16, 240. Okay, which is a nice even number, which is factorable and reducible. Okay, 240. What I should have done is actually written it down here. But that's okay, I'll remember. 15 times 16 equals 240. Just need the room. Okay, just like anything, we have the imaginary 1. I could easily write this as we're increasing. I could already tell that we are, because we have same signs. We're adding, but in a negative sense. 9/16. Okay, I'm gonna I'll just carry my work through here. That's fine. I'm gonna go 240. I've decided I'm just gonna do that. I could spend the time trying to find common numbers. 120, 15, does 16 go into 120? I don't know, right? I just divided this by 2. 16, 120 divided by 16, I doubt it. It is reducible though, 7.5, right? Okay, let's just work it out. So we have 16 times 4. 16 times 4, 64, right? Yes. Okay, so negative, don't forget the negative. 64. Negative. We're increasing. Same signs. That means we're increasing. Okay? Adding together, essentially. 15 times 9, 135. Okay, I'll double check that. Let's just move this over here. Clear. Hold up. Did I do that right? 15 times 9, just to double check. 135 plus 64 negative 199. Which is kind of a weird fraction, right? What goes into, we don't know all these, right? It's not something we memorize. We know that 240 could be reduced because it is an even number. That's pretty easy. We know that 3 goes into 9. Does 3 divide nicely into that? I don't know. Again, now we have to figure out, can we reduce? Whoops, wrong one. Calculator. So let's go 199 divided by 3. Yeah, that's a repeating. Okay, clear? 199 divided by 3. Again, it's just a random guess. It's not something we memorize, right? But we do know that 3 goes into 9. 4 doesn't seem like it would, because we know 4 goes into 200. 4 would go into 240. I'm not sure if we could reduce. It's just a matter of finding that number that would work, right? 199, I doubt 5. 6 probably not as well. 246 would go into 240, yes. 199 divided by 7, that won't work, I'm pretty sure. Yeah, it's really weird numbers. 199 divided by 8. I could go on and on and on, right? 8 doesn't go into it nicely. Oops. I think that's it, to be honest. I don't have an answer key, so I don't know. I'd have to double check somehow, some other way. Divided by 9, right? Okay, I'm gonna leave it at that. Just assume that that's it, right? Check my answers later. Again, that's the answer I get. Good job if you got the same. How are we doing for time? Yeah, we're at that time. There is one more. Let me clean this up quickly. This one will be a little better. 16 over 40. We'll do this one quickly. I like these ones, you know, are gonna work. Okay, and I'm gonna go like this. Negative 13. This is gonna be reducible, because now we have two denominators that we know are even numbers, and they can divide between each other, right? So I'm going to go with 40. I'm going to keep it at 40. Again, imaginary 1. I know that math rules, a positive times a negative is going to return to you a negative answer. Okay? That's what's happening here mathematically. So rewriting it, we have negative 16 over 40, subtract 13 over 20. For clarity reasons, that's what we're doing. Okay? It's nice and clean, and we can clearly see what's happening. All right, I'm going with 40 as my common denominator. I don't want to go any larger than that, because if I go any larger, you know, it's fine. I don't mind reducing, but the larger the denominator, then it's just more work, right? You can see that from the prior examples, right? Okay, so this is unchanged. Don't forget to bring your sign. Whoops. Don't forget to bring your sign. Okay, easy to forget. We have a subtraction here. Same signs, that means we're increasing. And times 2, so 13 times 2 is 26, right? Six and 2. Right? We're adding, so I mean, I know I'm saying adding, but please don't get confused. We're adding, but it's in a negative sense, okay? You just need to understand how this works, right? When you have two same signs, you're increasing to the left. The value is increasing, okay? Make sense? I hope so. All right, that's 12. Carry the 1, 3, and 4. Okay, so we end up with negative 42. This is reducible because we have two even numbers. I know I can reduce. I know 4 goes into 40. If I go 2, yeah, I think we're gonna end up with 2. So if I factor 2, whoops, I should start using that more. Okay, we have a negative. Don't forget the negative. I'm factoring 2, I get 21 over 20. 3 times 7 equals 21. 3 doesn't go into 20 nicely, neither does 7. Okay, so we end up with improper fraction, and then I can convert this quickly. Don't forget your sign, to a mixed fraction. There we go, that is it. Okay, again, I'll check my answers later. If that's what you got, I did that for you guys and gals that are actually practicing all those. Next video, we're going to go through finding each difference. They're basically the same examples, just more problems. Again, I recommend the more you do, the better you're going to get. And then also you increase your confidence in being able to do these type of problems. It's great to have you. Good luck. And yeah. Keep it up. Keep up the good work. Every single one of us supports you, including I. And I'll see you guys and gals in the next video. For now, take care.